Open Academy.
A light weightless bar is pivoted at its center and weight 5 newtons and 10 newtons placed 3 meters and 2 meters respectively from the pivot on one side. How far is the 20 newton weight from the other side? In the question here, we are not given the diagram, so we need to draw the diagram. And I have my ruler. I'm going to draw the diagram. Draw a straight line to illustrate the bar. I draw a straight line now. So I draw the other part. That's not good enough. Take it again. Okay, I'll manage. No. I'll do it again. Hope I get it this time. Okay, I think this is better. I take that down. And I take the other side. I take that up. Okay, I erase the excesses. I'm going to erase. Okay, I erase that. Then I go back to the question. Yeah, the question says a light weightless bar. It means that the weight is so small that it can be negligible. So in this bar, the weight is negligible, meaning the weight will not come on. Is not going to show in our diagram as we have here, but it's pivoted at the center. So I'll draw something that looks like this at the center to illustrate the pivot or the pivot at its center, and weight 5 newton and 10 newton is placed 3 meters and 2 meters respectively from one side. So I focus on this left hand side here. On one side we have two weights, and I'm going to draw the weight. The first is 5 newton, so I'm going to put it there. I'm going to put it down there. Yes, that's my 5 newton weight. Then another one is the 10 newton weight, and it's just on the same side with the 5 newton weight. So 10 newton weight now. And the question says both of them are placed 3 meters and 2 meters from pivot. So I need to draw the line from the pivot here to the left. There is 3 meters. So that's 3 meters. And the second one, the 10 newton weight to the pivot here is 2 meters. So that's the two weight, 2 meters from the pivot, and the 5 newton weight 3 meters from the pivot. That's on one side. Then the question goes, how far is the 20 newton weight from the other side? From the other side. So I'm going to, the other side is on the right hand side here. So where will I put the 20 newton weight such that the bar will be balanced? So it depends on the distance now. So is it how close to the pivot or how far from the pivot? to the other end. So let's assume it's somewhere around this point, and I draw it down now. 20 Newton weight. So the distance what we are going to find. Where are we going to put 20 Newton weight such that it will have a balancing effect with respect to the remaining 2 years? So the distance from the pivot, I'm going to call it x. Yes, let me call it x. Okay. So how far is the 20 Newton weight? That's x from the pivot on the other side to maintain this weight to be balanced on the pivot. Now let's calculate. So we have 3 forces here, 3 weights here: the 20 Newton, the 10 Newton, and the 5 Newton force. So to calculate now, we have to use the rule that says, or the principle that says, anti-clockwise moment is equals to clockwise moment. Now that's the principle we are going to use here. Now we need to identify the clockwise and the anti-clockwise moment, but we are going to be taking moment. About the pivot, taking moment about the pivot. The pivot, we call it C, so that point is called C now. And 20 Newton force, we have a clockwise effect, CW, a clockwise effect to point C, the turning effect. It will have a turning effect. With 10 Newton, we have an anti-clockwise, and with 5 Newton, we also have an anti-clockwise moment. So we have anti-clockwise and anti-clockwise. So those two we have anti-clockwise, while 20 Newton we have a clockwise, and that's the frame of reference. And you know that's anti-clockwise, and this is clockwise. Okay. So we are going to solve now. We are going to have 5. The first force here, 5 times the distance. The distance from the 5 Newton force to the pivot is 3 meters. 3 meters. So that will be 5 times 3. I close the bracket, plus the other anti-clockwise force, that's 10 Newton. From 10 Newton we have times 2, and that distance equals to the 20 Newton force as 20 times x. That's distance to the pivot. So we have 15 plus 10 times 2, 20, equals to 20x. So 15 plus 20 will give us 35, equals to 20x. Now we divide both sides by 20. We have 35 divided by 20 equals to 20x over 20. So that will cancel out. 5 here will give us 7. 5 here will give us 4. So we have 7, x equals to 7 over 4. Then that is one whole number, 3 over 4. So x equals to 1.75. 3 over 4 is 0.75. So that's the distance x at which we'll place with 20 Newton, so that the bar will be balanced on point C. That does it for this example. Let's check out the 5th example. This fifth example is just like the first example I did, but has a little difference. A uniform beam PQ of length 40 meters and weight 10 Newton is supported at P and Q. It carries a load of 4 Newton at a point 10 meters from P. What is the reaction at Q? So that's the problem we have here. And to start with, I'm going to draw my beam. The question says the beam is PQ, a uniform beam. So let me draw my beam. Now let me draw my beam. So I have my beam now, and the beam is PQ. So it means that one end of the beam is P and the other end is Q of length 40 meters. So the whole length of the beam is 40 meters from one end to the other end, and a weight of 10 Newton is supported at P and is supported at P and Q. So the weight of the beam is 10 Newton, and the weight continue in a while. It says the weight of the beam is 10 Newton, and 10 Newton, it will be concentrated at this point at the middle. So that's 10 Newton the weight, and the beam is supported at P and Q. That is the support is at P and is also at Q. That's two supports. So I'll fix that now. Okay, that's my support. Although I will still put my P and I'll still put my Q. So let me put my P there. Okay, so I have my P and my Q where the beam is supported, and it carries a load of 4 Newton at a point 10 meters from P. So I'll fix my 4 Newton force now. About this point, I bring that down as 4 Newton. So it's about 10 meters from the end P here. So to this point is 10 meters. Therefore, and remember the beam is 40 meters long. So from this point, from the center C here to the 4 Newton meter, we have 10, because half of 40 is 20. So from here to here will be 10 also. So from point C to point C is 10. So and the question goes, what is the reaction at Q? So that should be the reaction force. Let me draw that properly with a ruler. So that's the reaction force, and you know it's always an upward force. So let's call it Y. So what we are looking for now is Y. Though there will be a reaction force also at P, but the question doesn't require us to find the reaction force at P. I'll label that as X. So but what we are particular about is the reaction force at Q. So let's go on now. You know how we start. Anti-clockwise moment is equals to anti-clockwise, but before that, let's apply the first condition. Total upward force is equals to total downward force. And you know that is from the first condition of equilibrium. So that's X plus Y equals to 4 Newton plus 10 Newton, and that will give us X plus Y equals to 14 Newton. Equation 1. Those are the two upward and downward forces. Also, anti-clockwise moment, that's from the second condition of equilibrium. Anti-clockwise moment is equals to clockwise moment. So we go on taking moment about P, because we are looking for the reaction force at Q, and the reaction force at Q is Y. So we are taking moment about P. We are looking for the reaction force Y, so we will take moment about P. Now this force 4 Newton is going to give us a clockwise moment about point P. Sorry, I need to take this, it's not X, it's P. Taking moment about P, okay, about this point P. So this will give a clockwise moment. This will also give a clockwise moment, that's the clockwise direction. Then X will not give a moment, a turning effect, because it's directly in line with point P. Then Y will give a turning effect. There will be a moment of Y on point P, which is an anti-clockwise moment. You see, it will go the other way. Now we have two clockwise, and this will be anti-clockwise moment, ACW. So remember we said anti-clockwise moment is equals to clockwise moment. So Y now, Y times what? The distance, and that's the distance of the O beam itself. The distance of the O beam is 40 from this point Y. Then the force 10 Newton, which is clockwise, the force 4 Newton, which is clockwise, will be equals to 10 times the distance from this point of the force C down to point P. That's 20, close the bracket, plus the other clockwise force, that's 4 Newton, spanning through 10 meters to P. 4 times 10, we close the bracket, we have 40Y equals to 10 times 20 is 200 plus 4 times 10 is 40. So 40Y equals to 240. Then we divide both sides. Y is equals to 240 divided by 40. So Y equals to 6 Newton. So the reaction force at point Q now, which is Y, the reaction force at Q is 6 Newton. That's all we are required to find. So that does it for the example. And that does it for so much I can cover in this my first physics video lesson, Moment of Force, as inspired by my SS2 students. I love you guys. Thank you.